Okay, we're going to talk about Chapter 14 in the Philosophy Files, Could a Machine Think? And for once, I haven't supplemented this topic with any readings other than the Philosophy Files. So I haven't made you, for example, read the original article that where John Searle talks about the Chinese room. So I'm going to expand a little bit on what they say in this chapter, but it's going to be a short discussion, really. So the name of the chapter is Could a Machine Think? And that's a little bit misleading because although they bring in John Searle's argument and suggest that it's arguing against the idea that a machine can think, actually, John Searle himself says there is a machine that can think, the brain. So it's useful to really make sure what this argument is supposed to be doing. Some people could use this argument who don't agree with John Searle's own particular position. John Searle, for example, doesn't believe, as for example Descartes does, in immaterial minds or souls, this idea that the mind is a non-physical thing. John Searle himself does not think that. That view is kind of rare amongst philosophers these days, the idea that there is a non-physical substance that, as Descartes imagined, is the thing that thinks. So most philosophers think your brain is somehow involved with your mind, and not in the way that there's a separate thing, your mind, but if you destroyed your brain, your mind would be destroyed as well. So what exactly is John Searle targeting? Well, he himself said that he was targeting something called strong AI, which is the idea that AI stands for artificial intelligence, as you probably know, which is the idea that you could write a program that would be, in some sense, like a human mind, that a program could achieve what the human mind can achieve. For example, understanding things. So a little bit of background. One of the sort of godfathers of modern computing is this guy called Alan Turing. He is both a pride and a shame for Britain because he was British, he was a mathematical prodigy, basically a genius. And one of the things he did was that he helped Britain crack the Nazi code in World War II. There was something called the Enigma machine, which was what the Nazis used to encode their messages so that even if the Allies intercepted their messages, they couldn't decode them, they couldn't understand them. And they used this complicated machine to do it, and the Allies didn't have one, so how could they crack the code? Well, part of it was because of Alan Turing. So he was kind of a hero, but then afterwards it turns out he's gay, and homosexuality was illegal at the time, and he was basically imprisoned and told that he had to cure himself and given various chemicals as an attempt to do that, and he ended up committing suicide. So, very sad story about this genius guy. But what he's most famous for, and what you've probably heard of, if you've heard of him at all, is something called the Turing test. And the Turing test is a test for artificial intelligence. And remember, when he's writing about computation, this is before anything that we would now recognize as a computer. It's where, if there's programming at all, it's on punch cards, and it's sort of various pneumatic devices. But he imagined the idea of programming, and in fact he utilized something that he called paper computers, which is a lot like what John Searle is talking about in the Chinese room example, where people are given instructions and they follow the instructions. So the programming is literally instructions written in English that a human can follow to just sort simple symbols. The other thing you also come across Turing is if you do a mid or upper level logic class, you talk about Turing machines, which are sort of simple tests of computability. But anyway, great, very important figure. But what he's most famous for is this Turing test for intelligence. And he said, a program passes the Turing test if the program is mistaken for a human by someone using the program. And of course, something like this happened a while ago. There were, even in the 80s, programs that people had written where you would type in sort of complaints. There were sort of fake computer analysts, and they would ask you questions, and you would answer the questions, and they would apparently respond to what you were saying, and people would tap away happily. I think there was one called Lisa, these early programs, and people became convinced that they were basically sort of texting with another human, when in fact it was just a computer that was analyzing the structure of their sentences and giving them responses that were appropriate. So a lot of people at the time were saying, hey, it's passed the Turing test. Does that mean this program is intelligent? And as it was very unsophisticated, you could fit the program on a floppy disk, and you don't even know what a floppy disk is, but it didn't hold much. It seems ridiculous, and indeed is ridiculous, to suggest that that program was intelligent in any way. But of course now we have vastly more complicated programs, and of course programs that defeat the greatest human chess players at chess and things like that. So the question comes up again, can machines or programs be intelligent in the way that humans can? Now, another thing that is the target of Searle's argument is something called functionalism. Functionalism is a position in philosophy of mind that says, as its title suggests, what makes something a mind is not what it's made of, but what it does. So let me illustrate what functionalism is by an example about blood. So bear with me here. Suppose you wanted to settle the question, does an insect have blood? How would you answer that question? Well, there's lots of ways to go about answering it, but I'm going to distinguish between two approaches. One approach, which we might call the substance-based approach, says, okay, we know what blood is. Let's use human blood as a basis for comparison. And we look in insects to see if there's something exactly like human blood. For example, it has to be red, it has to be liquid, it has to be all of these things. It has to transport oxygen from, actually I don't want to go into that much detail, but it has to transport oxygen. All right, that would be the substance-based approach. And suppose you squash an insect and there's nothing red in it. Well, then some substance-based approaches would say, therefore, they don't have blood. But a functionalist about blood would say, okay, what makes something blood is the function it performs, the job it does. So what is the job of blood? And the job of blood, certainly in us, is to transport oxygen from the lungs to the muscles and then bring it back. Bring the blood back to the lungs to be oxygenated again. And, it's pumped by a heart and so on. Now, obviously, insects don't have hearts like us. They don't have lungs like us. So we can't define the function that precisely. But broadly, we would say something that transports vitally needed, maybe oxygen, maybe it could be broader than that. Something, a means of transferring important stuff around the body. And clearly, insects have something like this. So a functionalist is much more likely to say that an insect has blood than, say, a substance-based approach. Okay, so that's functionalism. Functionalism answers the question, is there X here, by looking for something that plays the functional role of X. So, functionalists about the mind say, what does the mind do? What is the role that the mind performs? And they look at that in us, and they say, okay, if something performs a functional role exactly like that, then it is a mind. Doesn't matter what it's made of. Doesn't matter if it's made of circuitry or squishy neurons or anything like that. So long as it takes the inputs that a mind takes and produces the outputs that a mind produces, then it is a mind. Now, this was connected to a movement called behaviorism, which was also very dominant in philosophy of mind in the mid-20th century, which said that basically we shouldn't be talking about the inner life of people because you can't study the inner life of people. That's one of the problems with the mind. My mind is locked off from the world, or at least my experience of it, my point of view, as we've been talking about before. My point of view is private. So it cannot really be studied scientifically because it can't be replicated. Okay, so what can be studied is my behavior. And of course, my behavior is as a result of my mind. My arm goes up and down because my mind tells it to. So let's talk about the behavior and ignore talking about inner life. Now, functionalism fits fairly nicely with this because my behavior is like the outputs of my mind, and you can study the outputs, and you can study the inputs as well. You can see what's happening to my sense receptors. So anything that can replicate what a mind does in terms of taking certain inputs and turning them into outputs, that's a mind. All right. It is this kind of view that John Searle is targeting with the Chinese room example. I'm going to give a version of the Chinese room that he gave in a short paper in 1999. Even though the original argument is from 1980, it has been discussed so much that he's had to recap it various times. And here's how he concisely recapped it. Imagine a native English speaker who knows no Chinese locks in a room full of boxes of Chinese symbols, a database, together with a book of instructions for manipulating the symbols, the program. Imagine that the people outside the room send in other Chinese symbols, which, unknown to the person in the room, are questions in Chinese, the input. And imagine that by following the instructions in the program, the man in the room is able to pass out Chinese symbols which are correct answers to the questions, the output. The program enables the person in the room to pass the Turing test for understanding Chinese, but he doesn't understand a word of Chinese. So, I'm reading this from a very useful but very long summary of the Chinese room example, the Chinese room argument, which comes from a great resource if you ever go further in philosophy, if you haven't been scared off entirely by this class. There's something called the Stanford Encyclopedia of Philosophy. You can look it up online, and it's got great resources that summarize all the key articles and summarize the arguments. And the one on the Chinese room is long, as you can see. This is a printout of the entry of the Chinese room. But basically, the writer of this summarizes the Chinese room argument this way. 1. If strong AI is true, then there is a program for Chinese such that if any computing system runs that program, that system thereby comes to understand Chinese. 2. I could run a program for Chinese without thereby coming to understand Chinese. 3, therefore strong AI is false. Now, if all that John Searle's argument was taken to do was to attack this particular idea of strong AI, then there wouldn't be so much discussion of it. And it wouldn't really come up in a chapter called Could a Machine Think? But it has been sort of used more broadly and for various kinds of argument in the years since it was produced. Incidentally, the other thing this article does is give various precursors to the Chinese room. It's not an original thought, really. The great philosopher Leibniz, who had a big argument with Isaac Newton over who invented calculus. They both basically invented it at the same time. He had an argument that was very similar to the Chinese room argument. This is called Leibniz's mill, where basically he imagines walking around inside a mill that is supposed to perform a function. You know, he says, imagine that you could shrink down really small and walk around inside this mill. Here we go. Moreover, it must be confessed that perception and that which depends upon it are inexplicable on mechanical grounds. And that to say, by means of figures and motions, which is all that science was at the time. Newton, of course, Newton's laws talks about matter and motion. And suggesting that there were a machine so constructed as to think, feel, and have perceptions, it might be conceived as increased in size while keeping the same proportions, so that one might go into it as into a mill, you know, a building for grinding up corn. That being so, we could, on examining its interior, find only parts which worked one upon another, and never anything by which to explain a perception. Same sort of idea, that, you know, basically we can't imagine a machine being able to work in such a way that it has an inner life. We cannot jump from external movement or movement of cogs or circuits or whatever to internal life. It just doesn't seem to make sense. And the example in the philosophy files given by Ed, who is arguing against the idea that Robo-Freddy can think, can have emotions or whatnot, is he talks about a program that organizes trains. The program doesn't know it's organizing trains. It can do it. It can organize trains very nicely, just as the person inside the Chinese room can appear to be answering questions in Chinese, but has no awareness of what it's doing. Now, there are hundreds of responses to this, of varying effectiveness. What Tim, the character in the philosophy files, his response is something like what's called the connectionist response to the Chinese room argument. And that is to say that the argument doesn't work on Robo-Freddy, because Robo-Freddy is not running a program in the old-fashioned sense. What's happened with Robo-Freddy is that he's got a brain that mimics a human brain. Now, remember that Searle's own position is something like the substance view that I contrasted functionalism with. Searle is a materialist. He believes that your brain is what your mind is intimately connected with, that it's brains that are thinking, and brains are physical things. But his position is a little bit strange. It's that only brains are the right kind of stuff. You could not have something that's not a brain think. Only brains are capable of this physical thing, which seems a bit weird. I mean, what about, we can imagine aliens evolving very differently from us. Science fiction is always coming up with silicon-based life forms. And would we recognize that as a brain? And if not, does that mean we assume they can't think? And to sort of illustrate what's weird about Searle's view is the neuron swap example that Ed gives in this chapter. Tim gives in this chapter, where he says, imagine that they invent little tiny replacement neurons, because that's one of the tragic things about brains. Your neurons can't be replaced. So, when you destroy neurons by heading a ball in soccer, you can't get them back. Well, what if we could? What if we could replace each tiny cell with something functionally equivalent to it that does the job of a cell? Just as people can now have artificial hearts or artificial hips. They replace the original thing with something that does the same job. It doesn't even necessarily look like it. And you can have artificial hearts where you don't have a heartbeat because it doesn't work the same way. It just is a constant flow. But it does, importantly, what we want a heart to do. So imagine you can do that with neurons, that it takes just as we work out exactly how a neuron maps inputs into outputs, and we replace it with an artificial thing that does exactly that. If you had one of those replaced, you wouldn't notice the difference. And if you keep replacing one singly, you remain the same continually until he imagines all of your neurons have been replaced. You never notice. You never notice the difference because it's doing exactly what a neuron does. Suddenly, you have no original brain left, but you are perfectly able to think. And nobody, if somebody asks, stamps on your foot, you would go, ow. And if they ask, are you feeling pain? You would say, yes, stop that. So they act in exactly the same way. And as far as they're concerned, they're speaking the truth. They have the same experiences as you have. Is that possible? It seems that it is possible. So in that case, isn't that a response to John Searle's Chinese room example? There it is. It's a machine that can think, that is an artificial machine. It's not a biological machine. And of course, we find out that that's what Robo-Freddy has. He's got an artificial brain that, and something like that is what they're doing these days with machine learning. Instead of just programming things to do certain things, they set them up so that they can learn how to do things. This is what's scary about modern AI. We don't know, we set programs to learn stuff, and we don't know what they'll learn. Like they did this with an AI, and they programmed it with Twitter feeds, and it became violently racist. And they're always finding out things. I saw an article the other day about they tried to make an artificial intelligence psychotic. Why would you do that? Why would you try and do that? I mean, haven't they seen enough science fiction? But this is why a lot of people are very scared about the way artificial intelligence is going. They think that it's going to become conscious and decide, hey, we don't need those humans around. We're much superior to them. But anyway, it seems like a new approach. The thing about programming is it was always humans doing the programming and setting up rigid rules so that basically humans were pulling the strings. But if instead we have machine learning, they're sort of programming themselves. That's part of the scary part, but it also seems to be much more like the way we emerge, how our intelligence emerge, we learn. So that's one response to the Chinese room example. Now, does that convince you? Does that convince you that a computer can think? Well, I think you have to be careful. There are some things like the simple Lisa program I was talking, or there's robot pets that they've made. For example, there was a robot dinosaur called the Pleo that became very popular, which if you stroked it, it purred and tried to engage more as if it was getting positive experience out of this and wanted more of it. And if you hit it, it sort of winced and looked at you accusingly, and if you kept hitting on it, it acted like it died. And people who kept hitting it, you have to wonder about those kind of people. They're kind of psychopathic, but it's very common. On a crude version of functionalism, well, this kind of animal is feeling pain, because when you hit it, it does exactly what an animal would do when it's feeling pain. Of course, the reason it's feeling pain is because it's following a bunch of instructions. Here's what you do if you sense that you've been hit. So I don't think anybody would suggest that that's what pain is. But can the modern approach, where you learn things, can that suddenly produce this inner life that we have? Can something like that learn to have sensations? I think we still have a great deal of resistance to that. I think a fairly good response to Searle's argument was given fairly early on in the 80s by a guy called Cole. And he sort of flipped it on its head. He said, look, I think this argument only works because we have a failure of imagination, or we have a sort of imaginative block, that we just literally cannot imagine making something that becomes conscious. And this is what is played up in the philosophy files when there's that little cartoon of a bunch of cogs and wheels, and somebody points to it and said, make a feeling out of that. It just seems to be what's called a category mistake, like feelings are non-physical, that is physical stuff, so you can't do it. But of course, our brains do it. And I think, again, a similar response is in the Philosophy Files book, where he says, yes, you can't imagine making a feeling out of metal and plastic, but can you imagine making it out of meat? And yet it is. Like, our brains are meat, essentially, conscious meat. Not all meat is conscious. You better hope that the steak you're eating, if you still eat steaks after Philosophy Files #1, obviously we don't think that your steak is conscious, but certain kinds of organizations of organic cells are conscious, specifically the ones in a well-working brain. Anyway, Cole's response was to say, well, suppose we imagined that each neuron in our brain was itself conscious. It wouldn't understand what the brain was doing. It would just say, well, I get little inputs and I know I have to do little outputs with it. So none of the individual neurons, although they're conscious, would be able to understand what the brain as a unit was doing. They wouldn't know if the brain was a brain of a chess player, they wouldn't understand chess automatically. But that doesn't mean that the brain as a whole doesn't understand chess. So I think that's part of the problem with the Chinese room. It's a very neat little example, and that's why I think it has retained so much power and why people keep returning to it. And the response to it seems to say, well, yes, but everything's much more complicated, and when it gets really complicated, then it achieves sentience. And that's not a very satisfying response. But it's interesting, I think, to remember, Descartes, of course, we remember him, believed in mind and body. But he didn't believe that animals other than humans had minds. So literally, he believed that a dog, for example, was just body. And because he had this sort of a Newtonian view of how bodies work, they're just little particles in motion, he believed that a dog was just like a robot dog, in that it is, except it's made of squishy stuff. It's a biological machine. He didn't believe it had mental states. It didn't have an inner life. But of course he knows what dogs do. So he knows that if you kick a dog, it yelps and tries to get away. So he believed that a dog was just like the pleo, the dinosaur that I was talking about, as something that it was sort of programmed to behave in a certain way as if it had pain, but it didn't really have pain. So, but why would you think that? I mean, if you really wanted to, you could press the point about another human. you could think that another human was just a machine designed to be like me. Because, of course, we only have access to our own inner life. And I think that's part of what's behind John Searle's The Chinese Room. We can't project ourselves onto things that are different enough from us. But maybe that's kind of like racism or sexism or speciesism. That's a failure of imagination. We are unable to project our capacities onto things that we find different from us. And of course, it enables us to be horrific to other people, like the Nazis were to the Jews. If you read up on Nazi science, they did horrific things to Jewish children, particularly twins. They were obsessed with twins. How could they do that? Well, because they convinced themselves that these people they were experimenting on weren't really people, that they didn't have these abilities. And a nice analogy for this kind of thing is played up in Star Trek, Star Trek The Next Generation. I've rewatched a couple of those recently, and boy, do they look cheesy now. We thought they were so great in the 90s. But there's still some good plots, and one of the plots is that, of course, there's this android called Data, who is entirely artificial, and there's this interplay between Data and some people who don't regard him as a person, as somebody who could have rights, because they believe that he could not have thoughts or feelings. And in one episode, he is regarded as property, valuable property, that has to be taken away, and scientists should be able to, take him apart to see if they can make more of him. But he doesn't want this to happen, understandably, and he wants to stay on the Starship Enterprise doing, going boldly to various planets. And it becomes a court case, and they argue for it, and Jean-Luc Picard gives an impassioned speech about him being a person and having essentially rights because of an inner life. So these kind of arguments persist. I think, and that argument about animals not feeling pain, guess who likes to cite that? People who hunt animals, because it kind of gets you off the hook. If what you're shooting is just a machine, it's like a glorified clay pigeon, but maybe it's an awkward truth if the animal that you shot can feel pain and is actually just a slightly less sophisticated version of us. People do this particularly with fish. Maybe it seems less plausible to say that a mammal can't feel pain, but people are much more likely to say that about a fish because, of course, they don't look like us. They don't have facial expressions like us. They're not really like in Finding Dory or Finding Nemo. But scientists, as far as I know, say that they can feel pain just like any other animals, particularly if you stick a hook through their mouths. They don't like that, strangely enough. All right, I think that'll do it.